investigative reporting, but then also graph it on your calculator if you want to see what this thing looks like. Just take a look at it, but you can solve, since there's no endpoints, there's no guarantee that you'll have a min and max because it doesn't fit extreme value theory. It's not on a closed interval. See it? Does it work? Was your intuition about what the derivative told you match the graph about a critical point?
Well, I didn't look at the graph, it just
Yeah. You know what I'm saying? Boom, but you get that one value. That one value. You see it? You guys, what's the derivative of this? Yeah, if you put it in front, it would be y prime equals negative 2x times e to the negative x squared. I want to know when, let's look at, so it's two things multiplying together. Is this thing ever undefined? Well, for the same reasoning here, like this thing is never going to equal 0. Because you can't raise e to something to make it the whole thing equal 0, so that's no good. And then this thing's never undefined. This thing never equals 0 for the same reason we were talking about over here. But then this does equal 0 somewhere. So that if you take the two things and multiply them together, when x is 0, your derivative is going to equal 0. Does that make sense? So what that means is you do have a critical point. CP, critical point, at x equals 0. And again, you determine that just by looking at this derivative. You know what I'm saying? Anything without a calculator. And if you look at the, and this is the only one, nothing else will make this thing equal to 0. And if you take a look at the graph, it looks like this. Hi! You know, it's like on the end, it goes, you know, it clears out like that. But right here at 0, it's got this little mountain. Are you guys looking at the graph on your calculators? Yeah. We'll get to that in another section. You know what I'm saying? But for now, you've located the critical point itself. You know what I'm saying? And it's the only one. And if you look at the graph, it is the only one. And you didn't have to look at the graph to determine that. You know what I'm saying? We'll get, what we're going to do is like we're going to create little tables, and we're going to see that the derivative is positive from the left, and the derivative is negative from the right, which means that the function was increasing, 0, decreasing, maximum. Does that make sense? So you just have to look at like just to the left and just to the right of it to determine that. And there's actually another way too, which we'll get to. Did that make sense what I just said, you guys? You know, it's like, how do you determine if it is a min or max? That's the question. We found the critical point, which is step 1. And now what we're doing in this whole section was just, okay, let's plug the x value into the function to determine the y value, and then just compare them. And that's what we're doing now. But what we're going to do later is still look at derivative like sine, the sine of the derivative. Remember we created those sine charts in Math 4? This is the whole reason why. It's kind of to build into this. It's sort of like a precursor. We're going to determine when the derivative equals 0 now, and then positive and negative means the original function was increasing, 0, decreasing, makes it a max. If the derivative is negative, 0, then positive, that means the original function was decreasing, 0, increasing, which makes it a min. Does that make sense? And there's also other times when it doesn't change sign. It'll be like positive, 0, positive. And that's neither a min nor a max, which we'll get to. It's like the x cubed function, that little bugger. X cubed. What's happening is 0. It's not a min or a max. Derivative equals 0 though, because that's 3x squared. Right? It's not a min or a max though.